Okay, 4.2 notes position, velocity, and acceleration. It says Mr. Bruce is playing catch with his best friend, himself. He throws a tennis ball straight up into the air. The height of the ball is modeled by S of t is equal to negative 4.9 t squared plus 18t plus 2, where t is the time in seconds and s is the height of the ball from the ground in meters. So here it gives us our position function, okay? Our position function is he throws the ball goes up, and then eventually the ball comes back down. That position function is modeled by S of t, which they gave us in the beginning as negative 4.9 t squared plus 18t plus 2. Okay, the velocity function is the derivative of the position function. So for the velocity, since we know that it's the derivative of the position function, I'm going to go ahead and take that derivative here. So I bring the 2 down. 2 times negative 4.9 is negative 9.8t plus 18. Okay, negative 9.8t, I know that's going to be a negative slope. Okay, and so it's going to look something like this. Okay. To get the exact points, I could plug in numbers to get those exact values. I just know that it's going to cross somewhere around 2. And then the rest, okay, I know it's negative, so it's going down. And then acceleration is the derivative of velocity. So I'm going to take the derivative one more time, and then I get negative 9.8. And notice negative 9.8 is a constant function. Okay, and that constant function is going to be about right here, okay, at negative 9.8. Okay, and each of these have units associated to this. So the position one said that this is t is time in seconds, s is height. So this is going to be no, not for this one. This is just going to be based off of t is time, and the whole thing is in meters. So the position function is going to be meters. The velocity is meters per second, and the acceleration is meters per second, or per second squared. Okay. So velocity is the rate of change of the position function. So if v of t is less than 0, that means the particle is moving left/down. Okay. If velocity is greater than 0, that means the particle is moving right/up. And v of t equals 0 means the particle is not moving. Okay. Average velocity is S of B minus S of A over B minus A. Okay, so think of that rate of change that we talked about. Velocity is the rate of change of position, so it makes sense that we're using the position function S of t and then plugging in values A and B to find the average velocity. Speed is the absolute value of velocity. And now let's talk about how do we know if we are speeding up or if we're slowing down. If velocity and acceleration have the same sign, the particle is speeding up. If acceleration and velocity have different signs, then that's how we know that the particle is slowing down. So if we look at these values here, okay, looking at each of these, notice, okay, these have different signs, and these ones have different signs. One's positive and one's negative, so we know that these are slowing down. Versus these values over here have the same sign. They're both positive or they're both negative, so we know that they are speeding up. Okay. We can also write the definition of displacement, which is S of B minus S of A. Notice that that is the numerator of the average velocity. And the total distance is just going to be the absolute value of displacement, because total distance is not negative. You can't have a negative distance. Okay. So the next part says particle motion from an equation. So the position x-coordinate of the particle moving on the x-axis is modeled by the function x of t is equal to t cubed minus 4t squared plus 3 for t greater than or equal to 0, where x is measured in centimeters and t is measured in minutes. So number 1 says find the displacement of the particle during the first 2 minutes. Well, we know displacement of the particle, this is going to be x of 2 minus x of 0. And then what I'm doing is I'm plugging in 2 and 0 into the function. So this is 2 cubed minus 4 times 2 squared plus 3, okay, minus 0 cubed minus 4 times 0 squared plus 3. Well, this gives me 8 minus 16, which is negative 8. So that means the displacement is going to be, negative 8 centimeters. Then it says find the average velocity of the particle during the first 2 minutes. So that's x of 2 minus x of 0, what we found in the first part, over 2 minus 0. So we know this is negative 8 over 2, which is negative 4. And average velocity is the rate of change for the position. So this is going to be negative 4 centimeters per minute. Then it says find the velocity of the particle when t is equal to 4. Well, the velocity, so v of 4, we know is just the same as the first derivative of the position function at 4. Okay, so I would take the first derivative. So x prime of t is equal to 3t squared minus 8t. Okay, and then what I'm going to do is I'm going to plug 4 into that. So 3 times 4 squared minus 8 times 4. This gives me 16 centimeters per minute. Then it says find the acceleration of the particle at t equals 4. Well, acceleration, so a of 4 is equal to the first derivative of velocity at 4, which is equal to the second derivative of the position function at 4. So I'm going to take the second derivative up at the top here, and I get 6t minus 8. So I'm going to plug in 4, so 6 times 4 minus 8 gives me 16. This is going to be 16 centimeters per minute, or per minute squared. Then it says, is the particle speeding up or slowing down at t equals 4? Well, the velocity at 4 was 16, which is positive, and the acceleration at 4 was 16, which is positive. So since they have the same sign, we know that this is speeding up. Okay. Now let's say we are looking at particle motion from a graph. So first we looked at an equation, now we're looking at a graph. It says the figure shows the velocity v is equal to x of t of a particle moving on a coordinate line. Number 6 says, when is the particle moving to the right? And then justify your answer. So we know the particle is moving to the right when v of t is greater than 0. So when v of t is positive, which means it's moving to the right at these values here. Okay, that is all the values where v of t is positive. It's greater than 0. Okay, so in the first one, we know that this is going to be 0 to 1. Okay, because that's this part right here, 0 to 1. But then we have to find this value here in order to write our next interval. So in order to find that value, we are going to have to find what the equation is for this line here. So let me change my colors. We need to find this. I don't want to do it that way. Let me highlight it a different color. We need to find this, okay? The equation of that line, okay? And in order to do that, we could find the slope by doing rise over run. So starting down here, this would be up 1, 2, 3. To the right, 1, 2, 3, 4, which means the slope is 3 over 4, okay? And then we can use the point right here, which is 6, 1, as our point, and then use y minus y1 equals mx minus x1. So this is going to be y minus 1 is equal to 3/4 x minus 6. Oops. X minus 6. Okay. So from here, I don't want to solve what this equation is because that's not what's going to help me. What's going to help me is finding out what this value is. Well, notice that this value crosses the x-axis, so that means I need to find what y is when x is equal to 0. Sorry, let me rephrase that. This is crossing through the x-axis, which means this is an x-intercept. So I need to find what this value is when y is equal to 0. So 0 minus 1 is equal to 3/4 x minus 6. Okay, solving for this, and again, remember, you can use that InSolve feature on Desmos. Okay, but it's ideal that you keep everything in form of a fraction. So this would be -1 is equal to 3/4 x minus 18/4. Okay. You would add that over to the other side, get common denominator, and you would end up getting x is equal to 14/3 when you simplify, which means this point right here is going to be 14/3, 0. Okay, so now we can finish our answer saying, okay, it's going to be from 0 to 1 and 14/3 to 7, since this is when v of t is greater than 0. Then it says, when is the particle moving to the left? Well, we know it's moving to the left when everything is less than 0. V of t is less than 0. So let me erase some things on here. Okay, and we know that it's going to be less than 0 at these intervals here, where all the function is below the x-axis. Well, that is going to be from 1 to 14/3. And again, this is since v of t is less than 0. Then it says, when is the particle's acceleration positive, negative, or 0? Okay, so let's start with positive. Well, we know the acceleration is positive when we see a positive slope. And the only time we see a positive slope would be from here, 2, all the way to 6. So from 2 to 6, okay, v of t is increasing. Okay, now let's look at negative. Okay, negative is when we have a negative slope, and we have a negative slope from, let's see, 0 to 2. Okay, and 0 to 2 because v of t is decreasing. Okay, so notice when the particle's acceleration is positive, not only were we looking for a positive slope, we were looking for when v of t is increasing. Okay, and notice from here to here we have some increasing value above the line. But when we're looking at the negative slope, we're also looking to see if v of t is decreasing. So from 0 to 2, this is where we have a negative slope, and notice that we have part of it decreasing. versus from 6 to 7, we have a decreasing slope, but this is only increasing. I'm sorry, we have a negative slope, and this is only increasing, not decreasing, since we don't have anything below that line. And then we don't have anything that has a 0 slope because we do not have any horizontal lines on here. Okay, number 9 says, when does the particle have the greatest speed? So it has the greatest speed at t is equal to 0 and t is equal to 2. And that is since the speed, absolute value of v of t, is equal to 2. Okay, so at t is equal to 0, okay, that is right here, t is equal to 0, and then t is equal to negative 2. Okay, notice that those are the highest and lowest values on that graph. Okay. Number 10 says, when is the particle speeding up? So remember, it's speeding up if it has the same sign. Okay, so we know it is speeding up at 1 to 2 because v of t is less than 0 and it's decreasing. And then we also know that it is speeding up at 14/3, 6 because v of t is greater than 0 and it's increasing. So again, looking at the graph here, okay, well, 1 to 2, so that's right here, 1 to 2, it is less than 0 because it's below the x-axis and it has a, and it's decreasing. And then we have 14/3 to 6 right here. It's a positive slope and above the x-axis, which means it is increasing. And then the same thing for a different sign. Or in other words, when is the particle slowing down? This would be from 0 to 1 and 6 to 7, since v of t is greater than 0 and it's decreasing. And then also from 2 to 14/3 because v of t is less than 0 and the function is increasing. Okay, remember when we're talking about decreasing or increasing, we are looking at acceleration there, okay? Because remember, for this to be slowing down or speeding up, we're looking at a velocity and acceleration. For it to speed up, velocity and acceleration have to be the same sign, so both negative or both positive. And for the particle slowing down, velocity and acceleration have to be different signs, which means one has to be positive and the other has to be negative. Okay, so now you guys are working on the homework/practice.